Thank you for joining us. In this video, we will look at how we can use the remainder theorem to determine the coefficients of a polynomial using a system of equations. So we have f of x is equal to this polynomial where p and q are constants. The remainder when f of x is divided by 1 is 7, and the remainder when f of x is divided by x minus 2 is 1. We want to determine the value of p and the value of q. All right. Well, f of negative 1, all right, if x plus 1 was a factor, which it's not, then negative 1 will be a root. But we can say, hey, f of negative 1 is going to be negative 1 to the fourth power plus p times negative 1 to the third power plus q times negative 1 plus 5. All right. If we evaluate that, we're going to have positive 1 minus p minus q and plus 5, and we know that that has to equal 7 because the remainder is 7. All right, then continuing our use, we know that on division by x minus 2, so if we evaluate f of 2, we're going to have 2 to the fourth power plus p times 2 to the third power plus q times 2 plus 5. And if we evaluate that, that's going to give us 2 to the fourth power, 16 plus 8p plus 2q plus 5. And we know that that value is going to be equal to 1. So now we have a new system of equations that we can solve. I'm going to rearrange my system of equations just a little bit. And so 1 plus 5 is equal to 6. So I know that negative p minus q is equal to 1 because 1 plus 5 is 6, 7 minus 6 is 1. And then my other equation, we have 8p plus 2q. And if I do 16 plus 5, that is, what is 16 plus 5? 21. And then 1 minus 21, that means I'm going to have a negative 20 over there. So a variety of ways that I could solve this particular system of equations. I'm going to go ahead and say that let's multiply everything here, right, by 2, right, on both sides. And so that's going to give me negative 2p minus 2q is equal to 2. And I have 8p plus 2q is equal to negative 20. If I add these two equations, I have 6p, right? That's going to be 0, so I've eliminated there. And negative 20 plus 2, that's going to be negative 18. And so from this information, I know that p will be equal to negative 3. And if p is equal to negative 3, that means that q, right, let's see here, negative p minus 1 must be equal to q. So q then must be equal to negative 4. All right. So important to recognize that we can use the remainder theorem here, and when they talk about a remainder, it lets you have the idea. And if I'm talking about two remainders, then I'm probably going to have two equations with these two unknowns to solve. Let's go ahead and use our NumWorks calculator to verify our solution to our system, and I'm going to solve it like this before any math. All right, so let's say that this was a calculator active question. I would say 1 minus p minus q plus 5 is equal to 7. That's one equation. And 16 plus 8p plus 2q plus 5 is equal to 1. If I solve that equation, we look to see our solution, and then we say, oh, well, hey, wait a second. Why do we have a different value to our work? Well, that's because we have to be careful with our answers. And we see over here that that Q is incorrect. And that's where we say, don't try to do all the work in your head. Use your use your written out response to double check, and we see, hey, negative 3 minus 1, that's equal to q. So that's going to be positive 3 minus 1 is equal to q. And so we recognize, oh, right, we want to be careful with our work. We have our correct solution, negative 3 for p and q for 2. Right, so a lot of students will initially go do the work, and the mistake that I showed there are mistakes that can frequently happen, and so that's why you want to make sure that if it's without a calculator, you're writing everything out to make sure you don't make a careless mistake. Okay, thank you for your time.